Hello everyone, today we are looking at another Leetcode problem. This is 1353. Find the maximum number of events that can be attended. Now in this problem, we are given an events list which is nothing but the window of start and end time. And the constraint that they have given us is that we can attend an event if and only if the start time is lesser than or equal to d and the end time is greater than or equal to t, which means my event, if today is the date, my event has either started today or earlier, and my event is either ending today or later. Okay, along with that, the other constraint is that we can only attend one event a day. Now we have to return the maximum number of events that we can attend. Now, to understand this problem better, let's look at one example. Let's say events is equal to 1, 5, 1, 5, 1, 5, 2, 3, 2, 3. Now, let's plot this on the number line. So, let's say this is 1, 2, 3, 4, 5. Okay, so this is one event. This is another event. Now this is another event, and then we have 2 to 3 and then 2 to 3. Okay, so the events are written like this. Now on day equal to 1, I have these three options. Out of this, I can pick any, they're all the same. So let's say I pick this one. On day 2, I have these four options. Now among these, I want to pick the smallest window because I want to leave these other two for covering 4 and 5, which is not possible by the smallest. So I would first like to exhaust the smallest window always. Okay, so let's say exhaust this one. Then when we come to 3, I have these possibilities. And out of that, again, I want to exhaust the smallest one. So let's exhaust this one. At 4, I have these two options. I can exhaust any. And then at 5, I have only one option. So I can exhaust that. So if you notice, what happened was we went day by day. And what we did was, as we went day by day, we had multiple choices. And in those choices, we always picked the one that was ending first. Okay, so what happened was pick the shortest or earliest ending window. Okay, so this was a condition that we were applying as we were progressing. But in order for us to process these events itself, what was very important was to have these events sorted by start date. Started by start date. And this is important because I am progressing day by day. And I want to have all the events that are starting either today or earlier than today as my left hand side. I cannot have it on my right hand side, then this whole execution flow gets messed up. So this is the first condition that we need, that you start with the sorted array, which has to be sorted by the start date, and then as you're executing, the second thing that you do is you pick the shortest window, which is ending earliest. And this is it for the problem's logic. Here it is a little bit tricky because we have to take care of both the start and end time. Usually problems involve sorting in a specific manner, which is like either by start date or the end date, which helps you get to the solution. But in this case, even if I said sort, let's say sort events by start comma end, even if I said this, what would happen is first it will pick all the events that started earliest. So 1 5, 1 5, 1 5, and then 2 comma 3 is coming at last. But what happens is when we are at d equal to 2, our decision is not based on the way it has been sorted. It is based on the number of options that are available at d equal to 2. So we cannot have some sort of a sorting logic ahead of time for me to get this. So what I will have to do is I will have to sort it by start time, and I have to progress day by day, checking how many events do I have which are starting today or earlier than today, and then from those how many of them are ending the earliest, and pick the top from that, because we need only one event to attend per day, right? So we'll pick the shortest one. So that's how the logic works. Now let us look at the pseudocode to solidify this concept. Okay, so let's look at the pseudocode. So let's say def max event, which takes events, and this is nothing but list of list, which is, and finally we are supposed to return the the maximum number of days that we can attend events. So this would be an integer again. So we start with sorting this input, and what we'll say is we will run a counter for every day till we reach the max day, which is going to be max of every event end date. Okay, now we will also have a min heap. I'll show you how we are using that. So for that, do import heap q in Python. Alright, we will also need events pointer. So as we progress day by day, if you remember, as we progress day by day, so here I'm progressing day by day, I am also creating this window. Okay, this is the window which is actually nothing but the heap, min heap, and this window or this particular min heap will always give me event first with the shortest end time. So that's what we want to execute here. So we have a min heap here, and at the same time the pointer to keep progressing through the events. So let's say we start at the 0th one, and total to give me the maximum duration of days that we covered events. Okay, so let's start the for loop now. So for d in range of 1 to max day plus 1. So we're going day by day, and now for every day we will see if, let's say this is my events array, and my events pointer is pointing here. So I want to check if this is actually starting earlier or equal to today. And then if it is, I keep adding all of the events that are starting earlier than equal to today, and then stop when I find an event which is starting later than today. So I stop there. So let's do that. And the reason why I am doing this, right, if you look at it, what we are trying to do here is create this. So at this point, when d was equal to 2, I did not have these two events in my min heap, right? So I had to add it to my min heap in order for me to retrieve this particular event. So that's the operation that we're doing of updating our min heap so that we can fetch the smallest ending window. So if events pt is less than the length of events array, and if events of events pt is lesser than or equal to current day. Very good. This is a window that I want to consider. So let's add it. Okay, so let's now add it heap q dot heap push into our min heap, but I want to fetch the one that is ending first, right? So I will store it as end comma start, and then once I have processed this, move the pointer to the next element. So events pt plus equal to 1. So this loop is done, where I'll keep processing all of the events where the start date is lesser than or equal to today's day. Alright, so once this has been done, now my min heap is updated. Okay, now I can pull the latest one from min heap, but there is a catch. The catch is that maybe we had, let's say, 1 comma 5, 1 comma 5, 1 comma 5, also 1 comma 2, 1 comma 2, 1 comma 2, let's say. So first time we picked 1 comma 2 at d equal to 1. Second time we picked this at d equal to 2. Now when we come to d equal to 3, this one has expired, which means picking this would be wrong. This is an event that has already expired. I can never attend it. So this is the only case that we have to take care now. I will have to exclude. I'll have to keep excluding if I keep seeing such events. But other than that, if this condition does not satisfy, then the first one that I get would be the event that I can attend. So let's do that part. While min heap, okay, I will get n comma start equal to heap q dot heap pop of min heap pop of min heap. Okay, so I've gotten that. Now if my end is greater than or equal to d, okay, now that means that this is a valid one. So at the first valid one that I find, I stop and end. So I'll say total plus equal to 1, and then let's break from here. Otherwise you keep popping till you find the first valid one at which you can break. And that's about it. I will return total by the end of it. Now if you look at the time complexity here, the first time complexity that we'll have to look at is here. So here we are spending n log n for sorting, and then on for max duration, what we are doing is for every element we are, let's say if we had if we had one event starting every day, then this would be for every n I am pushing it to the heap. This takes log n times, and this we are doing this n times. So this is another n log n. Likewise, when we are popping it, we are popping, and let's say, so this is worst case, n log n. So the time complexity is overall n log n. That's about it. That was it for this problem. I'll see you again with the next one. Thank you. Bye bye.